Problem number 13. Suppose the curve C has position vector r of t is cosine t sine t comma t squared. So for the first part here is find a vector tangent to r of t when t is equal to pi. So to do this, we know we need the derivative r prime of t. Okay, so this is r prime of t. And then the next thing that we need after that we have r prime of t is that we need to plug in. So I said t is equal to pi. We need r of pi and r prime of pi. R of pi, plug in pi up here. Cosine of pi is -1. Sine of pi is 0. And then pi squared. R prime of pi. Negative sine of pi is 0. And cosine pi is, again, -1. And 2 times t, 2 times pi. Okay, so then to write down our parametrization, all we have to do of t is make this r of pi, -1, 0, pi squared, plus t times our direction vector, and the derivative evaluated pi here gives us our direction vector, 0, -1, and 2 pi. So that's part A of the problem. And now I say write down, but do not evaluate integral for the length of this part. So the length of the part of C between t is equal to 0 and t is equal to 2 pi. So our arc length integral in general is, I said, t is running from 0 to 2 pi. It's the, let me not put a square root here, it's the magnitude of the velocity vector. It's the speed vector, sorry, speed. Speed is a scalar quantity, I shouldn't say speed vector here, dt. So how do we find this speed? We take the magnitude up here. So negative sine t quantity squared plus cosine t quantity squared plus 2t squared dt. Integral from 0 to 2 pi. This plus this will give you 1. Check that for yourself. 1 plus 4t squared dt. And so what we'll say this is good. This should look like an integral you can evaluate using calculus 2 methods by various trigonometric substitutions. This is all I'm asking you to do in this problem.